This is an acid-base titration. It's lab number 7 from the Advanced Chemistry with Vernier lab book. That experiment's appropriate for college or AP high school chemistry. It's also similar to experiment number 24 in the Chemistry with Vernier lab book for regular high school. We're going to do it today with a computer and a LabQuest, and I'm going to show you some of the equipment that you're going to use to do this lab. We'll start with a stir station. This is our magnetic stirrer, and it has some LEDs I'll turn on here and then turn on the stirrer itself. This stir station has a built-in ring stand. It can also be run on batteries or through AC power. The stir station today is powering a little micro stirrer that's a paddle wheel essentially attached to the bottom of the pH sensor, keeping a good flow of the solution going past the glass bulb of the pH sensor. This blue pH sensor going through the drop counter is what's going to be taking the pH of our titration. The drop counter itself is made of 2 pieces. This part is the part that actually counts the drops. An infrared beam of light goes through this little slot on the top, and as the reagent reservoir here drops through the slot, they will break the beam and count each drop. The software will then convert those drops into volume in milliliters. These 2 sensors, the drop counter and the pH sensor, are connected into the LabQuest interface. And for this particular lab, we're going to attach the LabQuest to a computer through a USB cable and control the titration with Logger Pro on the computer. So on the computer in Logger Pro, I'm going to open an experiment file from the Advanced Chemistry lab book. In the Advanced Chemistry with Vernier folder, I'll open up lab number 7. Now there's A and B. A is with a burette and B is with the drop counter, and we're using the drop counter, so I'll open 7B. I'm all ready to go. I just need to click on collect, and now it's waiting for me to start dropping the drops through the drop counter, and here they come. So here comes our data, and we just need to let this progress as our titration proceeds. I put some phenolphthalein in here, and you can see as each drop goes in, we're getting some pink. It's lingering longer with each drop, so we're really close to the equivalence point now. And it looks like we are there. We'll let it keep dropping a little while longer so we can get an upper tail on our titration curve. So here's our completed titration data. We want to find the equivalence point of this. So if you look at this pH data, you can see that probably between these 2 drops is the largest jump in pH, but that doesn't give us a very accurate reading doing that. So what we would do is find the first derivative of this data, and in the Logger profile we've already done that for you on page 2. So up here in the toolbar, I'm going to click on the next page button, which takes us to the first derivative. The peak of this first derivative peak is going to tell us what our equivalence point volume would be. If I turn on the examine button on the toolbar and come over here to the peak, it is showing us that the volume is around 3.2 milliliters for that equivalence point. Even better than first derivative though is second derivative, so I'm going to close out this first derivative, go to the next page button again, and here's our second derivative, and our equivalence point is going to be right where that second derivative crosses the 0 line. So to find that point exactly, I'm going to zoom in on this whole area where that action is happening with the zoom key here on the toolbar. All right, so there's the area of interest. If I select a region right about like that, where it is a linear curve right along where it crosses 0, I can then click on the linear regression button on the toolbar, and it fits a line to that section. I then go to Analyze and Interpolate, which will interpolate along that curve fit line. And if I carefully move that around until my derivative is as close to 0 as I can get it, right there, my volume is 3.27. That is the best number we can get for the equivalence point of that titration. So that was an example of a strong acid, strong base titration. If you're using the Advanced Chemistry with Vernier book, that experiment continues with a weak acid, strong base titration using acetic acid. And then in both books, there are several other titrations to do, such as one with a diprotic acid and things like that. So there are many things that you can do as a titration in chemistry courses.